Hi everyone, today's lesson is lesson 22 and it's division with and without remainders. As we take a look at your learning targets for today, I'm going to pull out the most important one, and that's the one in the middle, and it's to interpret the remainder for a given context. So basically what that means is this. When you divide, sometimes you have a remainder and sometimes you don't. And there are a lot of scenarios in math we look at like word problems, but real life scenarios where it doesn't make sense to have a remainder. Good mathematicians look at answers, at quotients, and decide if a remainder is appropriate or not. I'll explain a little bit more of what that means in just a moment. So I'm just going to scroll down and review something with you really quickly. Looking at division, like I said, today you're going to look at problems where there is no remainder. For example, 15 divided by 5 is 3. And then, of course, when there is a remainder, 16 divided by 5, you end up with 3 remainder 1. I'm going to try to scroll just enough so you don't see my writing. This writing is from earlier in math class. Can I do this where my screen isn't blocking it? Can I move this? Oh, look at that, I can. Excellent. Okay. So take a look at this problem. 50 trading cards are to be placed in protective pages. Each page can display 8 cards. How many pages can be filled? What's the least number of pages that are needed to protect all of the cards? Please pause this video and give it a try and unpause when you're ready for me to talk through the solution. So I'm going to talk through my thinking really quickly. We have 50 cards and 8 cards fit in each page. So ultimately I need to start by taking 50 divided by 8. That doesn't go evenly, we're going to have a remainder. So you can see right here where I've worked it out, long division style, I ended up with 6 remainder 2. So 50 divided by 8 is 6 remainder 2. Really what that answer is telling us is that when we're putting all of our trading cards into these plastic sleeves, we completely fill 6 pages and we have 2 cards left over. So 6 full pages, remainder 2. So 2 remaining cards left over. I was saying this morning in class, let's pretend that these are like old school LeBron James cards and you really don't want them to get damaged. These cards really do also need to get in these protective sleeves. Even if that last sleeve that you use isn't full of cards, it's only going to have 2 in them. We need to move up to the next card or the next sleeve because it doesn't make sense for us to say 6 remainder 2 pages or sleeves. We need to just go up to the next whole number. So in order to protect all of our cards, we're going to need, when it says what is the least number of pages that is needed, we need to go up to 7 pages. Not just 6 remainder 2, we need 7 full pages. That last 7th page, again, will only have 2 cards in it, but a more appropriate answer is 7 pages. This right here is not the most appropriate answer. So that's where good mathematicians stop and decide, is this a reasonable answer? In math, that's a key vocabulary term. Mathematicians ask themselves, is this answer reasonable? So this is not, but 7 pages is. Let's give it another try right here. We have a question about boats. I'm going to stop right there, pause this, give it a try, and unpause when you're ready for me to solve. All right, so at an amusement park, 16 people were waiting in line for the water ride. Each boat can hold 6 people. Just looking at A right here. So what's the least number of boats that are needed for everyone to ride? How do you know? Ultimately, we have 16 people. Each boat holds 6 people. I need to take 16 divided by 6. And when I did that, when I took 16 divided by 6 right here, I ended up with 2 remainder 4. So I was saying earlier today, if I were the person running the amusement park, it wouldn't make sense for me to say to my staff, hey everyone, just a heads up, we need to run 2 remainder 4 boats this afternoon. It's not reasonable. You don't run a remainder of a boat. You can't run part of a boat. You just have to run another boat. So 2 remainder 4 is not a reasonable answer. We have to just run a 3rd boat. That makes sense. So your most appropriate answer is 3 boats. An extension question for you is this: how many people are in that last boat? We know that it's not a full boat. We only have 2 full boats. That's our whole number up here, 2 full boats. How many people are in that last boat? You get that answer from your remainder, 4. 4 people will be in that last boat. This is just a quick review of divisibility rules for the numbers 2, 5, and 10. Those are things you've practiced for a very long time, and I don't need to waste any time in your video reviewing those. And last but not least, let's just stop and pause here for a moment. Without dividing, so I'm asking you to do a little mental math. Without dividing, decide which 2 of these division problems will have a remainder. Obviously, you can see that I've already circled the 2. This is from earlier in math class today. But even though those are already circled for you, just pause for a moment, take a look, make sure you understand why. Can you look at those problems and automatically know that those will have a remainder? Why do you know that? And move forward. That's it for you for today. Thanks for watching and have a great night.